So another name for chloroform is trichloromethane. Yeah, and chloroform is actually a colorless liquid. The boiling point is about 60 degrees Celsius. Yeah, it is slightly soluble in water and is miscible with nonpolar solvents, for example, hexane, or for example, ether itself. Yeah, it's got this very potent anesthetic properties and has got analgesic effects as well. So not only chloroform will knock you unconscious, but it also remove the pain or from if it's actually given to administered to pregnant mother or mother in labor. So it will knock the mother unconscious, which is very good. Yeah, you kind of want it in a sense, and it also has the painkiller effect. So the pain is it's no longer there in a sense. Yeah. Problem is that chloroform causes the serious cardiac arrhythmias and is also toxic to the kidneys. Yeah, and it has also these carcinogenic effects as well. So you don't really see chloroform much in current practices. Yeah, there are other better GE and so on. Yeah? But at that time, yeah, around 1800, in 1900, he was one of the best, one of better three, compared to nitrous oxide and compared to ether. So let's have a look at the stability of chloroform. Yeah, so chloroform can actually undergo anodization. If you have hydroxide, for example, you can actually pick up the lone the single proton here, and this reaction is rapid. Yeah, forming the negatively charged trichloromethane in a sense, and it can also cause the release of one of the chloride, forming 1,2-dichlorocarbene. And as you know, carbene is a nucleophile. It's quite reactive as well. And chloroform can also decompose further. Yeah, under oxygen, under light. Yeah, it can form peroxide. Yeah, and it can actually it has these two pathway of degradation, or two pathways of decomposition. The first one actually form chlorine gas and carbon dioxide and HCl. The other one is actually form phosgene, which is a very toxic gas. Yeah, and phosgene, fortunately, can be quenched with ethanol, yeah, to form this carboxylic acid dilute ether. So one way to actually, if you happen to work in pharmacy that actually has one of these bottles of chloroform, and you know that you don't actually use it as frequently, yeah, just need to add a bit of anhydrous ethanol to quench and this phosgene gas. Therefore, you can stabilize the chloroform solution. Yeah. Chloroform. So chloroform is a good anesthesia. So people then try to modify chloroform to make it a better one. Yeah. So another analog of chloroform, you can see this is the start of chloroform and replaced with bromine, and you have this trifluoro compound. Yeah. Moiety, and this is called haloethane. Yeah. The RS form of the haloethane is the active form of the GA. Yeah? And again, if you see haloethane, it needs to be kept in a dark amber bottle with thymol, because if done otherwise, you can remember that it would actually produce phosgene with HBr and HCl, which is not what we wanted. Yeah? There's also the isomers of or another analogs of this haloethane as well, or chloroform. We have enfluorine and isoflurane. Yeah, quite stable chemically. If you remember your that the carbon CF bond is quite stable. It's one of the most stable bonding. Yeah, so it is quite stable chemically, and it has been used as a inhalation anesthetic.